So, hello everyone, and thank you very much for joining the event. So, what I wanted to do is a very particular presentation tonight. While everyone that I see is trying to explain AI, let's say in the most advanced, even the most complicated way, I will try to do the opposite. I will try to make you grasp the main concept of AI in a very practical way, but so that even a kid could understand it. Now, why should I start from this presupposition? Well, because in the Vortex group, we already have some very good presentation about AI, such as the one made by Yu Jan. And I don't think I could ever compete, let alone equal, with this presentation. That's why I would like to make something of my own. So first of all, before starting, given that this presentation will be also recorded, I would like to thank the Vortex for inviting me. It's an awesome group, so whoever see it, please join. I posted an non-ending link on the right. And personally, I develop all my code, and I have my Python community called Python Kai. Code first, code fast, never rest. You're all welcome. And as last, I'm a member of my community called Yitum, which has been participating in the Vortex as well. Feel free to join, and if you do enjoy the world of finance and cryptocurrency, that's for you. So let's actually begin not explaining exactly what is AI, but specifying why most of the time when AI is explained, it simply fails. Okay, very simple, because whenever you open let's say a book, whenever the explanation begins, well, it's hyper complex. So you start already from a very complex form. That is called, for example, the cost function, which I will never explain. But you already start with a high degree of complexity. And that is a problem, because it's not that you immediately understand complex stuff. You have to decode them, you have to articulate them. And especially, essentially, with a formula such as this, I exactly know what it means, but why? Because I have already background concept, I already studied AI, etc., etc. So if you start with this, you're probably going to think you're making a step which is longer than your leg. So my idea is, how do I properly teach things? Well, I start from a very, very simple model that even a kid could understand. And later, of course, I will start explaining what it is and how to use it. And only then I climb up to a higher degree of complexity so that you can understand even more and more complex things. I think this is definitely the best approach. And also, this is not the approach used in artificial intelligence. So, now, before actually another thing, for example, another curious thing, what was the worst kind of example you could ever use? Many people, for example, they start talking about AI and they start giving you examples. And they give you examples of cat and dogs because, well, that's archetypical, essentially. And he essentially tell you, well, you take those two common elements and then you try to make an example out of it. And the example couldn't be worse. Why? Because it's this kind of data, okay, it's so complex to express, to communicate to people, because if you look at images, well, they're just set of bytes clumped together, and so this creates a tensor, a multidimensional matrix. It's too complex. So my idea is, let's make it as simple as possible. How do I do that? And let's start. So to understand AI, first of all, you have to understand a simple concept: data. When I refer to data, I always imagine an Excel file. I always refer to an Excel file. Why? Because the data. It's basically two-dimensional, or well, it's multidimensional. But what I see on the screen is something which I can understand. We've always been using Excel, and it's a form, a spreadsheet, something that we can all understand very easily without even training. So what I'm going to express here very quickly is what is dimensionality, because for some people this is obvious, but for other people who did not undergo a formal training, the idea of dimensionality it's something that they still need to understand. So very simple. When I refer to dimensionality and I convert it to my Excel file, I mean the number of columns. So when I have like two columns, as you can see here, well, then I have a two-dimensional field. When I extend it to 3 columns, I have 3 dimensions. If I would have only 1 column, and have these are the samples, so different observation, different pieces of data, well, that is just 1 line because it's just 1 dimension. And I can increase the number of dimensions. This would mean that if I had 4, this will turn into a 4-dimensional field. And I mean, a 4-dimensional field, it's something that we cannot grasp, we can see as time. But then what if I have 5, 6, 7, 8, 100 dimensions? So you don't think about something complex like a graph. For now, think about just an Excel file. Now, let me start with a very simple example. Wine. Wine is something, okay, so we have 3 kind of wine, 3 kind of observations. And from this kind of wine, I have 6 dimensions in total. So I have 6 indicators, 6 pieces of data that I grasp from every bottle of wine. So for example, this is a white bottle. And I say, what's the pH? The color is white. The age, how many years, the taste, etc., etc. I do that for every wine. Now, to create your own AI, you have to, there is one very simple rule you have to follow at the beginning of every single, of every single model. You divide the data. How do you divide it? You choose 2 parts, the predictors and what you want to predict. So essentially, you choose 1 or multiple, but let's say 1 value which you want to predict. And let's say, for example, you want to predict the name of the wine, as you can see as the violet color. And now you choose the other, which are predictors. And what essentially is saying, I want to read the pH, the color, age, taste, country, and without knowing the name, I want to estimate that. I want to find out what is the name, what is the value that I want to predict. That's the simple rule. You have to divide the data in those 2 parts. Now what do you do? Now let's even simplify the concept even more. So you put them apart. Those are called features and is the predictor. Usually we have more predictors than predicted. And then you want to predict one value, which you call label. But I will only use predictor and predicted, or what we want to predict, in order to make it simple. So you place them apart, and then the AI find the rules. So that is essentially, and what happens, this is called training. So you put predictors and what you want to predict on the sides, and the model is trained. Now the special part. Now, so this is a model. This is what is an AI. It's something in between the 2 parts. Now, what happens next year? Let's say you have new wine, like 1,000 bottle, and you want the AI to find out what's the name, as you can see here, right? We had all the predictors and the name. Now, the AI is already trained, so right now we have the feature, the predictors, the model, and what will the AI do? From the predictors and the model, then it will estimate the new names. So this is essentially how AI works in layman terms. It couldn't be easier than that. And theoretically, it's very easy how it's played. Now, let's just increase complexity a little bit more. Let's say, okay, how does finding the rules, how does creating this model works? So what happens is that I have my Excel file, and of course, how many dimensions does this wine data set have? In total, I have 6 dimensions. I cannot graph it. So let me make something very simple. In this case, I still have my data, only 2 dimensions, so I can graph it. And at the same time, I divide it in 2 parts, which are feature and label. So I follow my first rule, and then I say, okay, I want to find the relationship between, please, I heard something. Is everything all right? Oh, okay, sir. Please. So what happens is that yes, the AI will be defined. These, I'm sorry, the AI will find what are called the rules, and is essentially this line over here, and this will serve as a model. So right now, which if I have a new data, which is new feature, let's say I have D, and the D is placed right here, then and only then, with the model will guide me. I can estimate what's the label. This is called regression, when essentially the label has numbers. And so you may think and say, okay, when do I have to use the regression? When I have to use another model classification? Well, sometimes you want to predict values which are numerical. Okay, I only introduced these two simple concepts to give you a bit more complex idea of what's going on. So when you can predict numerical values, or you can predict categorical values. Let's say the name of the wine, that is categorical, but some other time I switch. So instead of using this as a label, then I want to use the color, and the age of the wine, or the pH, that's numerical value. So I'm going to use regression, and for the other part I'm going to use classification. So those two basic kind of AI, regression and classification. Classification is a little bit different because the names, the categorical values, so it means they have no numbers. You cannot place them in a mathematical field unless it's called encoding. But what happens? So same principle. You define your feature, mathematical feature, then your label. So the predictor and what you want to predict, and then you divide the data, and what divides the data, what estimates this right here, this model. So AI follow always the same principle over again. Now, to broaden up a little bit in the field of AI, you have two possible approaches, which is supervised learning, and what it means is that sometimes you have the luxury to have feature and label. So what you want to predict, you already know what. So the predictor, and you already know what you want to predict, like I explained. Some other times instead, you don't know what you want to predict. You only have data. Let me give you an example. If you have a lot of clients, okay, you have 1,000 clients, you have a data set, you run an e-commerce website, then usually your data set will look like this. You don't know what you want to predict. You only know that you have some data. Now, when this is the case, you don't have the label. You don't have what you want to predict. This is called unsupervised learning. And essentially, the entire point of unsupervised is grasping something useful from this chaotic data. For example, you can say, okay, within your 100,000 customers, there are 10 segments. This is called customer segmentation. There are 10 useful segments that you can use to classify, let's say, your customers. That's one use. There are many other uses, let's say, but let's keep it simple. So if we give a proper definition of AI, which is it's kind of impossible. The more you know, the more appropriate is your definition. So I just wrote something which is very, very easy now that you have a 2-minute experience on the explanation of AI. And the first one is predictive values when given some predictors. So what I've been doing with the different colors, if it's supervised. And if it's unsupervised, extraction information out of chaotic data. That is, and what does it mean is AI is a very precise set of algorithms that can allow you to do very specific stuff. There's no magic with it. It's a set of tools, essentially. And now, another interesting part, which you will find useful, it's, okay, so let's say that I am a company, I own a company. Okay, what does it take, essentially, to run an AI? And what I mean by that is, okay, so what can I actually do it as a little company? Do I need an expert? Do I need to be a big tech? Okay, so you need data, which you as a company already have. You need computing power, and you need someone who can code, because almost any AI right now is still coded. I haven't found a software which I can use like Excel, like Microsoft Word, essentially that allows you to run AI without being an expert. Probably there are, but trust me, they are not so common, especially uh, among the ones who code AI. Now, the GPU power, mostly right now, is basically is free. Unless you want a very specific demanding AI, but most of what I've been saying, finding predictors and finding predictors, the data set, about clients, about wines, about products, customer segmentation. It's all free. You don't need computing power unless you are very very big as a company. But mostly, I can run with my own computer. I can run million of rows in like 30 million of rows easily within like 10 minutes. So you don't need that is completely free. What you still need is somebody who knows how to code AI to put it into a form understandable for the computer and to make the analysis for you. That so far hasn't been beaten. But there are companies who are trying to simplify that as well. And of course, every single year the challenges to enter the AI world diminishes, because it becomes easier and easier to code AI. To code a neural network, for example, 5 years ago, it was taking 300 lines of code. Now, if you make still something simple, it can take 5, 10 lines of code. So the barriers of entry to join AI are diminishing. And this is what interestingly is called cloud computing. So you basically you run a program, and instead of using your own computer, you need, as I specified, GPU, computing power. And that is the computing power you can find online. And sometimes those two notebooks, for example, which offers it, are free. But sometimes when you do something demanding, they make you pay. Now, the last very interesting point about AI before starting the discussion, I should add a few points, is the size of the model. Now, you may think that actually, for example, I'm an AI developer, so can I actually do all kind of AI? Can I actually code all sorts of AI? Well, no. I can only code what I call the homemade models. It's something very simple, okay, that even it has a great computing power, I can run on my own. But then there is the models which Google use and Amazon, the big techs, which have tremendous amount of cost. Just to create them, it costs tens of millions. The latest, for example, model to generate text has cost Google 12 million to train. And it's giant. It's not something I can do on my own. Now, the big tech, like giant models, can I access them? Yes, some of them actually I can. And for example, Jensen is a free library that allows me to use words. How to say? How to say to use embeddings, which is a very complex AI tool in my speech, in my in my coding, in my programs, and that's open source. But some other times you find, like especially image recognition models, and they are owned by especially big techs, and they are not free. For every use you have to pay, and sometimes for some companies that's okay because they are okay with that. But some other times when you scale your product, for example, you cannot use those kind of giant Google AI, because the cost is exorbitant if you scale it. And for example, that's a very good example. Those are AI that recognize objects, and also they tell you, okay, how many objects you have, the segmentation, and the kind of object detection. I can never do something like this on my own. I can do a simple model, so I can do one AI that only recognize might, or only recognize one of them, a dog's, for example. But to have something that generally and comprehend everything, I can never do it on my own. Why? Because I'm incapable? No, because it requires too much data and millions of dollars of training. But especially for images really require a lot of data, a lot of computing power. It's not something I can simply do on my own. Nobody can. And the last part, I'm sorry for the title. I hope is appropriate. Now, the issue, another issue with the AI, and I think is because it has been the way it has been published and many people got involved. It is not it doesn't have a defined hierarchy. So whenever you go to study AI, the problem is like when you study easy stuff, let's say what I've been teaching you, okay, that everybody agrees. You don't find so much misconception in it. All the terminology is the same whenever you search. But sometimes, for example, whenever you complicate stuff, everything changes. You cannot find sources, and the terminology changes. Especially, for example, the definition and the difference between machine learning and deep learning. Well, yes, the deep learning uses a very particular architecture. I'm not going to explain that. But for example, to actually differentiate between machine learning and deep learning is impossible because there are machine learning models, for example, which do not use deep learning. Other machine learning approaches that uses deep learning, but only deep learning model which uses deep learning. And this is just an example how chaotic is still this young discipline, especially among academics. And I believe because there is the rush to publish everything you can publish because it's something hot. And until the market is oversaturated, well, there is this everything is being chaotic. And this is just an example of a hierarchy I created on my own with my notes. So as you can see here, I start with supervised and unsupervised learning. Everything has a structure. But then there is other kind of data. There is sequential data. There is spatial data, natural language processing, which is text, which is a part of sequential data. And all of these combine in different hierarchies, and they have a ton of different tasks. And so to find out an order between this chaotic world, it requires months, and it requires somebody who knows the basics. And so I think it's time to finish the presentation. I didn't want to get into what the AI can do. It just give you a very simple understanding of what AI is. And hopefully we can continue that in the Q&A. Thank you.